So we continue with implies. So implies, or also if only, I like to say that this is just like cause and effect. Easy for us later on to understand if we assume this is as cause and effect. So for examples, let me have it is a rainy day. And Q as I use umbrella. Like that. So if we have a proposition P implies Q, so it will sounds like if. So the keyword if will be in front. If it is a rainy day, then this is the continuation. I use umbrella. Okay, so let us observe here the keyword if and follow with the keyword then. Okay, if it is a rainy day, then I use umbrella. We can try to look at another examples with the combinations of another logical connectives as we already have here. For examples, negation. P implies negation Q. Remember the use of negations in the previous video is by adding the keyword not. So with this, how is it sounds? That will be if it is not a rainy day. I see I missed the wording day in here. Okay, then we can put that, but for the sake of English, instead of not, we can make use don't. Use umbrella. Like that. So what I would like to highlight, for the implies still we use the keyword if then, but for the negation we use the keyword not, just to indicate. Okay, that's how we do it. Combine two or more statements by using implies. But then how is it the truth table for implies? So we have statement P, and then we have statement Q, and then the combination statement P implies Q. So the truth value, the combinations will be the same because it's only two statements, true, true, false, false, and then true, false, true, false. Okay, so it's a bit unique, I would like to say, for implies, because in implies it will be false only in the situations the first statement true the first statement true, so you can look at row 1 and row 2. But the second statement is false, meaning we are referring to the second row in here. So only if we have these situations, then the implies will be false. The rest, that will be true. Like that. So you can see, only in the situations the first statement is true and the second statement is false, then the implies will be false. Let's take a look the previous example here and then try to arrange the statement for this one, meaning P true and Q F. But at first I will just mention first that it is true, it is true. So if we would like to arrange the second, I'm referring to these situations and then see how we end up with the propositions. So the first one true, meaning if it is a rainy day, then this is this is P and it is true. Then we should have Q with F, meaning negative or not. Then we will say, then I'm not use umbrella. So we know that this is not Q and it is false. Now, you tell me, how is it these propositions sounds? We know that if it is a rainy day, by all means we should use umbrella. But here said, if it is a rainy day, then I don't use umbrella. So in a logical sense, it's something wrong in there. So that is why in implies roles, this call as a false, as in the second row. So first statement true, second statement false, the result is false. This is the easiest way for me that I can explain to you to understand about implies. Okay. So the next one, Biimplies. So Biimplies with two arrows in there, we call Biimplies if only if. There is also another terms vice versa. Also we can say that Biimplies is just the same with if we have two statements, for example, P implies Q, so it will be equivalent with P implies Q and Q implies P. Because if we read PB implies Q, P if only if Q, meaning P if P then Q, or the other way around, if Q then P. So which is if P then Q and at the same time also if Q then P, like that. For examples, let's have P statement. John call. Q, Mary call. Let's just assume this is true and this is true. So if we create another statement by combining these two statements, then we are going to have John calls if only if Mary calls, just like that. Okay, so the keyword if only if there. So John calls if only if Mary calls. Or also if we are using the others definitions of Biimplies as it is here, we also can arrange another statement but still hold the same truth value. It will be sound like if John calls, then Mary calls. And if Mary calls, then John calls, also like that. So two ways in here. Now, how is it the truth table for this Biimplies? So we are going to have P and then Q. Oops, hold on. So Q and then P Biimplies Q. Okay. So the truth value for this one also the same: true, true, false, false, true, false, true, false. Okay. So for this Biimplies, it will be true whenever both statements have identical truth value. So if you are looking at this table, the possibility is on row 1 and the last row, row 4, which is true, true, they are identical, or false, false here, they are also identical. So in these situations, they are true. So either both true or either both false, that will be true for Biimplies, while the rest that will be false. Like that. Also, you can try to prove this value. You can prove this value whether it is true or not by try to construct the truth table for P implies Q and Q implies P. So take some time and prove or construct this truth table. and then see whether you are going to have identical truth value as we have in here. So it must be true, false, false, true as well. Okay, so that's Biimplies. So now the last one here, that will be XOR. Now XOR XOR, that will be using these operator symbols, XOR. So as mentioned, XOR is either true or false, but cannot be both here. Cannot be both true, cannot be both false. So either one must be true. So it cannot be both true or both false. That is XOR. So if you are looking at the truth table for Biimplies here, if you can try to projecting the XOR into the Biimplies truth table, then we are going to have P, Q, and P XOR Q, then the possible truth value combination, true, true, false, false, that will be true, false, true, false for Q. So here, so based on the definitions, is either true or false, but not both. So with XOR, that will be true when never either one of them is true. So you are going to see on the second and on the third row only here. So with this situation, or combinations of truth value, that will be true, while it will be false for the rest. So Biimplies and XOR is the other way around of truth values rules in this case. Of course, you can make or try to arrange your own examples for XOR, but this is how it is. And we already discussed all the logical connectives, start from negations earlier, and then the truth table, and then followed by conjunctions, disjunctions, and then implies, Biimplies, and XOR over there. So take your some times and try to understand again one by one all the 6 examples for the 6 logical connectives that we just discussed earlier. So number 1 in here, number 2, and then number 3, and number 4, number 5 in here, and number 6 for XOR here. So understand, I wouldn't say for you to remember, but understand the concept of each, the logical connectives over there. Okay, so on the next video, we are going to try to see how we can construct based on the half of the truth table from the 6 logical connective we just have earlier, to construct the truth table for more complex propositions or statements or combinations of statements we call it in there. Okay, so we already talked about statement again. Let me wrap up a little bit. And the logical symbol, we use alphabet and capitals. There are 6 logical connective we already discussed. Yeah, I not yet mentions the precedence. Precedence means which one comes first after which. In math operator, we already know. In math operator, we already know that multiple come first, and then division, and then plus, minus, like that. So in logical connectives, so we are going to have like negations is the strongest one, followed by conjunctions, disjunctions, and then implies and Biimplies. And then of course, whenever there is a bracket, then we must solve the one in the bracket first and then follow with the rest, like that. Okay, so the next one we are going to see how we can construct truth table for more complex structures in the for the combinations of 2 statements or more in that, and follow with the rest, law of logic, tautology, contradictions, tautological equivalence, and argument in the end. Okay, so we continue to the next video with construct truth table. Stay tuned and see you on the next video. Thank you.